Hi guys, this is O-level chemistry, paper 2, specimen 2023, question 7. Peroxodisulfate ions S2OA2 minus reacts with iodide ions in aqueous solution, and the equation is given over here. This produces 2 moles of sulfate ions and iodine. Iodide ions are oxidized in this reaction. State how the equation shows this. So we have got iodide ions that are being converted into iodine. So iodide ions have a negative charge, whereas iodine has a charge of 0, which means both the iodide ions lost an electron. So we can say that we can write this equation if we want, and we can say that iodide ions are converted to iodine by losing electrons. And since loss of electrons is oxidation, this proves that iodine ions are oxidized in this reaction. Okay, next, table 7.1 shows how the relative rate of this reaction changes when different concentrations of peroxodisulfate ions and iodide ions are used. Okay, so we have got a table in which we have got 5 different experiments that have different concentrations of peroxodisulfate ions, different concentrations of iodide ions, and the relative rate of reaction. Okay, using the information in table 7.1, describe how increasing the concentration of each of these ions affects the relative rate of reaction. Okay, so what we need to do here is we need to figure out the effect on the rate of changing the concentrations of one of the reactants by keeping the concentration of the other reactant the same. So if you look at experiments 1 and 2, we have the concentration of S2OH2 minus doubling. How do we know it is doubling? Because if we divide 0.016 by 0.008, we obtain a value of 2. But in these two experiments, the concentration of iodide ion remains as 0.02. So there is no change in the concentration of iodide ions, meaning whatever effect on the rate there will be, it will be because of the doubling of the S2OA2 minus ion concentration. So what is the effect on the rate? So now we have 3.3 as the rate of the second experiment and 1.7 as the rate of the first one. When we divide 3.3 by 1.7, we end up with a value of 2. That means if the concentration of S2OA2 minus ion is doubled, then the rate of reaction also doubles. In a similar way, now we need to find out two experiments in which the concentration of S2OA2 minus ions remains the same, but the concentration of iodide ion changes. So if we look at experiment 4 and compare it to experiment 1, we have got both the concentrations as being 0.008. That means the concentration of peroxide disulfide ions is not changing. However, if we look at these two experiments for the iodide ion concentration, we have 0.02 in the first experiment and 0.04 in the second experiment. When we divide 0.04 by 0.02, we end up with 2. That means the concentration is doubling. And what is the effect on the rate? We have rate of experiment 4 as 3.4, which will be divided by 1.7, and this also gives us a value of 2, which shows that if the concentration of iodide ions is doubled, then the rate of reaction also doubles. So what have they asked us to put down? They've asked us to put down the effect of peroxide disulfate ion and the iodide ion. So for peroxide disulfate ions, we compared experiments 1 and 2. And what did we see? As the concentration of H2OA2 minus ions is doubled, the rate of reaction also doubles. So this is our conclusion for peroxide disulfide ions. And for iodide ions, it is the same conclusion, but we have compared experiments 1 and 4 in this case. So we would write comparing experiments 1 and 4 as the concentration of iodide ions is doubled, the rate of reaction also doubles. So we have concluded our analysis of the effect on the rate of the iodide ions as well. Part C. Iron 3 ions catalyze this reaction. Explain how catalysts increase the rate of reaction. Okay, so what is the effect of a catalyst? A catalyst lowers the requirement of activation energy. First of all, we would write catalysts lowers the requirement of activation energy. That is the purpose of a catalyst. So, what effect does lowering the activation energy have? So, here we have ions in solution. So, ions in solution are colliding with each other, right? And the collisions are effective as well as ineffective. So the effective collisions result in product formation, whereas ineffective collisions do not result in anything. So by lowering the activation energy requirement, the number of effective collisions is increasing. Why? Because by lowering the activation energy, the number of particles that have energy equal to or greater than the activation energies have increased. And when the particles with increased energy will collide with each other, they would result in successful collisions taking place. So we will continue our statement. We have written catalysts lower the requirement of activation energy. So a greater proportion of collisions are successful because now more particles possess energy above the activation energy. So we have explained how a catalyst is involved in increasing the rate of reaction. Question 8. Copper reacts with concentrated nitric acid to form copper 2 nitrate, and the equation is given. State what is state the meaning of AQ. So AQ represents aqueous, and now we have to explain what aqueous means. So aqueous is a substance that is completely dissolved in water. So we will write AQ represents aqueous, which means a substance being completely dissolved in water forming a solution. So anything that is aqueous is a solution of that particular substance. Part B. An excess of copper is added to 25 cm cube of 16 mole per dm cube nitric acid. Okay, use this information together with the equation to calculate the volume of NO2 formed. The gas volume is measured at room temperature pressure, which means 1 mole of any gas under these conditions occupy a volume of 24 dm cube. And we need to find out the volume of NO2 produced. Okay. Show your working and state the units. Okay. So first of all, we will find out the number of moles of nitric acid that are reacting. So the concentration of nitric acid given to us is 16 mole per dm cube, which means we have 16 moles present in 1000 cm cube of nitric acid, of which we are only using 25 cm cube. So we need to calculate the number of moles of nitric acid present in these 25 cm cube. How will we do that? We will divide 25 by 1000 and multiply this value by 16 to give us 0.4 moles of nitric acid that are being used up. So we have found out the number of moles of nitric acid. Now, according to the equation given, 4 moles of nitric acid produces 2 moles of NO2. So the next step would be finding out the number of moles of NO2. So the molar ratio according to the equation is 4 is to 2, which is the same as 2 is to 1. Therefore, the number of moles of nitric acid that we calculated was 0.4. So the number of moles of NO2 would be half of 0.4, which is equal to 0.2 moles. So now we have moles of NO2. Now, moles of NO2 are present, right? 0.2 moles of NO2 are present. Now, from 0.2 moles of NO2, we need to find out the volume of NO2 that was produced. So, we had already discussed that 1 mole of any gas at RTP occupies a volume of 24 dm cube. So, the quantity of NO2 produced was 0.2 moles. So, 0.2 moles will have what volume? So, this would be 0.2 divided by 1 multiplied by 24. And when we do this, we end up with a value of 4.8 dm cube. So our final answer would be volume of NO2 is 4.8 decimeter cube. And if we want to put this in cm cube, we would write 4800 cm cube. Next, part C. When heated, copper nitrate decomposes to copper oxide, NO2 and O2. Construct the symbol equation for this reaction. So basically we need to put down the actual equation for the decomposition of copper nitrate. So we would have 2 moles of copper nitrate being heated, and this heating symbol is delta. This would produce 2 moles of copper oxide. It would produce 4 moles of NO2 gas, and it would produce 1 mole of oxygen gas. So this is the balanced equation for the thermal decomposition of copper nitrate. Part D. To a small sample of copper nitrate, a student adds aqueous ammonia drop by drop until it is in excess. Describe what is observed. So, first we need to describe what happens when ammonia is added dropwise, and then we need to explain what happens when ammonia is added in excess. So, a blue precipitate is formed on addition of ammonia dropwise, which dissolves in excess of ammonia to form a dark blue solution. So when ammonia is added dropwise, a blue precipitate forms, and when ammonia is added in excess, this blue precipitate dissolves and a solution is formed, and the color of the solution is dark blue, and it is also called deep blue, whichever you want to put. Okay, the next part asks us the student repeats the experiment but adds aqueous sodium hydroxide instead of aqueous ammonia. Describe what is observed. So the difference in the reaction of sodium hydroxide with copper ions compared to ammonia with copper ions is that the blue precipitate is formed on addition of both the solution dropwise, but in ammonia, this blue precipitate dissolves to form a dark blue solution, whereas the precipitate does not dissolve on addition of excess NaOH. So we will write a blue precipitate forms which does not dissolve on addition of excess sodium hydroxide. So this is the observation with sodium hydroxide. Question 9. Iodine reacts with chlorine to form iodine 1 chloride, ICl. Part A. Iodine 1 chloride reacts in a similar way to bromine. Iodine 1 chloride reacts with ethene in an addition reaction. So ICl will be added onto ethene, right? Draw the displayed formula of the product of this reaction. So we have ethene in which the double bond will open up. We have four of its hydrogen atoms placed on each of the carbon atoms. And when the double bond opens up, one of the two carbon atoms will have an iodine bonded to it, while the other would have a chlorine bonded to it. So this is the structure of the product when iodine 1 chloride reacts with ethene. Part B. Iodine 1 chloride reacts in a similar way to chlorine. Iodine 1 chloride reacts with ethane in a photochemical reaction in the presence of ultraviolet light. State the type of reaction that takes place. So, in the presence of ultraviolet light, in an alkane, which is ethane, hydrogen will be substituted by the halogen atom. So, the type of reaction taking place is a substitution reaction. Okay, next part. Suggest a symbol equation for the reaction between iodine 1 chloride and ethane. So now we need to substitute a hydrogen atom with a halogen atom. So let's just substitute one of the atoms. So we have ethane, which is C2H6 reacting with iodine 1 chloride, which is ICl. So we replace one hydrogen. So C2H5 and we replace it with iodine. And the hydrogen that has been replaced joins the chlorine atom in forming HCl. So this is the symbol equation for the reaction between iodine 1 chloride and ethane. Part C. The dot and cross diagram of a molecule of iodine 1 chloride is similar to that of a molecule of chlorine. Draw the dot and cross diagram of a molecule of iodine 1 chloride. Show outer electrons only. So here we have a covalent molecule formed between an iodine atom and a chlorine atom, in which one electron from iodine and one electron from chlorine is being shared. So now we complete the electrons of the individual atoms. If we allot X as the atoms of iodine, so we include 1, 2, 3, 4, 5, 6 at electrons of iodine, and we have represented chlorine with a circle, so or a dot. So 1, 2, 3, 4, 5, 6. These are the six other electrons of chlorine in its outermost shell. So this is the dot and cross diagram of iodine 1 chloride. Part D. Iodine 1 chloride reacts with chlorine to form iodine 3 chloride. The reaction is investigated at 200 degrees Celsius in a closed system. The reversible reaction reaches an equilibrium. Okay, and the equation is given. Part 1. Describe two features of a reversible reaction at equilibrium in a closed system. In your answer, refer to the rate of reaction and to the concentrations of the reactants and products. Okay, so we need to describe two features of a reversible reaction. The first feature of a reversible reaction is that the rate of forward reaction is equal to the rate of the backward reaction. Okay, so this is one feature of a reversible reaction. The other thing that they mention is that to include concentrations of the reactants and products. So we will write when equilibrium is achieved, the concentrations of the reactants and products do not change with time. And here we have included the rate of reaction as well as the concentration of the reactants and products in describing the features of a reversible reaction. Next, in part 2, they have asked us the pressure of equilibrium mixture is increased. So this is an information that they've given us. The temperature is capped at 200 degrees Celsius. ICl is a dark brown gas and ICl3 is a yellow gas. So what we will do here is first, just to recall, ICl reacts with Cl2 forming ICl3, and the color for ICl is dark brown and the color for ICl3 is yellow. This is just for our reference. So now what they have asked us is predict and explain what will happen to the color of the equilibrium mixture. So if the equilibrium is moving in the forward direction, the color changes from dark brown to yellow. Or in other words, we can also write that the intensity of the dark brown color decreases and that of yellow increases. This is another way of writing this. Okay, so now we need to explain this prediction. So what is happening? We are increasing the pressure, right? As stated in this part. So, and first we need to explain increase in pressure shifts the equilibrium towards the side with the lesser number of moles, right? So here the side with the lesser number of moles is the right side. So we continue our statement, which in this case is the right hand side. Question 10. Air contains a mixture of gases, including the noble gases neon, argon, krypton, and xenon. These noble gases are monoatomic elements. State what is meant by monoatomic. Basically, monoatomic means consisting of a single atom. So we will write here monoatomic means consisting of a single atom. And now we will describe the statement, which remains unbonded, unlike atoms in a molecule, which forms a bond with each other, right? Okay. Next, state why noble gases are unreactive. So, noble gases are unreactive because they have a stable electronic configuration. You can also mention in brackets, they have a complete octet. Right? Now, because of this, what happens is they do not need to lose or gain electrons, and hence they are unreactive. Next, state why fractional distillation can be used to separate a liquid mixture of neon, argon, krypton, and xenon. So, fractional distillation makes use of the property of boiling point. So, if fractional distillation can be used to separate these, that means they have got different boiling points. So, we will write since all of these gases have different boiling points, they can be separated using fractional distillation. Part D. State which noble gas, neon, argon, krypton, or xenon, has the fastest rate of diffusion at 20 degrees Celsius. So, looking at the periodic table, we find out that the one of out of these gases with the lowest AR value is neon. So, we will write neon has the fastest rate of diffusion. Now they are also asking us to explain. So the explanation will be the process that we just followed. So we will write since neon has the lowest AR value, its atoms are able to move the fastest, right? The lower the mass, the faster the movement. Part E. Air also contains oxides of nitrogen that are pollutants. State 1 adverse effects of oxides of nitrogen in the air. There are two adverse effects of oxides of nitrogen. I will mention both of them here so that you remember these and can recall if asked. So, first adverse effect is called the photochemical smog, and the second one is called acid rain. So these are the two adverse effects that oxides of nitrogen cause in the atmosphere. Next, with the aid of a symbol or word equation, explain how oxides of nitrogen such as NO are formed within a car engine. Okay, so first of all, we have got nitrogen gas in the air reacting with oxygen gas in the air, right? When this happens, we end up with 2 moles of NO. Now, nitrogen from the air reacts with oxygen from the air. But if this is reacting, there must be something that is causing the reaction to take place, which is the heat of the car engine. So, these gases do not react under normal conditions, they react at high temperatures. These temperatures are reached when the car engine is running. So, nitrogen and oxygen react to form nitrogen monoxide. Question 11. Table 11.1 shows some information about the homologous series of unbranched carboxylic acids. Okay, their name is given, their structures are given, and their boiling points are given. Okay. One of the characteristics of a homologous series is that it has a general formula. Part 1. Deduce the general formula for the homologous series of unbranched carboxylic acids. So the general formula for a carboxylic acid is CnH2n plus 1 and COOH. Next, describe two other characteristics of a homologous series. Okay, so one of the characteristics of homologous series is that they've got the same general formula. There are four other features or characteristics of a homologous series. They've asked only for two. I'm going to mention all four here because we need to recall them when asked. So the first one is successive members differ by a CH2 group. So look at methanoic acid HCOOH and ethanoic acid is CH3COOH. CH3COOH has an additional CH2 group, right? Come to propanoic acid, CH3 is there, but between CH3 and COOH there is a CH2, so an additional CH2 group. So this is one of the characteristics of a homologous series. The next one is they have the same functional group. They have the same functional group. Okay, the next feature is they are all having similar chemical properties. So we will write they have similar chemical properties. And the final one, look at the boiling point. The boiling point is increasing. So we will say that their physical properties change with a trend. Now, what is that trend? Here we can see that the boiling point increases along the series, right? So we can mention that in brackets here. Boiling point increases along the series as represented in the table above. Part B. An aqueous solution of propanoic acid is a weak acid. Define the term acid. Now, be very careful here. They are not asking for a strong or a weak acid, just what an acid is. What is an acid? An acid is a substance that releases H positive ions in an aqueous solution. Okay. Part C. Butanoic acid reacts with ethanol to make an ester. State the name of the ester made by and draw the displayed formula of the ester linkage. Okay, so the alcohol part is ethanol. So the name of the ester would start with ethyl, and the acidic part would be of butanoic acid. So the name of the ester would be ethyl butanoate, right? Ethyl comes from ethanol and butanoate comes from butanoic acid. Ethyl butanoate. The displayed formula of the ester linkage would be C double bond O and single bond O. This is the displayed formula of the ester bond. Part D. Ethanoic acid is liquid at room temperature. Okay. Describe the changes in the arrangement and movement of molecules of ethanoic acid when it is heated from room temperature to 120 degrees Celsius. So it will convert into a gas, right? Now, how do we define this? We will say as the temperature increases, the molecules gain kinetic energy. Okay, we can also say they gain kinetic energy and move faster, right? So by gaining energy, they are moving faster. Now, when they move faster, they also move a greater distance. So we will write this results in the molecules moving further away from each other, right? They move further away. Now, what happens is when they were closer together, they had an ordered arrangement, right? Now that they are moving further away from each other, they have a more disordered arrangement or irregular arrangement or random arrangement. So, continuing this sentence, we will include resulting in a more irregular, or we can also use the term random, irregular or random arrangement of molecules.